So you write a Lambda function, you click deploy, you test it, and it takes 1.2 seconds. Cool, you push it to production, but suddenly, half your users are complaining about 2-second delays, while the other half, they're getting lightning-fast 100-millisecond responses. Welcome to This Explainer. I'm your host, and today we're going to solve a mystery that plagues developers everywhere, a mystery that causes serious frustration, downtime, and honestly, costs businesses serious money.
Now, to understand why this inconsistent latency happens, we've got to strip away the magic and look exactly at what is going on under the hood when AWS Lambda runs. Today, we'll be covering 1. The Serverless Illusion, 2. The Execution Environment, 3. The Database Connection Trap, 4. Surviving flash sales, 5. Hidden traps and retries, and we'll wrap it all up with 3 rapid takeaways.
All right, let's jump right into Section 1, the Serverless Illusion. Just keep in mind as we go that your serverless compute code doesn't just float around in the ether, it actually needs a completely isolated box to run in. AWS Lambda is serverless compute. You hand AWS a zip file or a container image and they run it. But without that secure isolation we just mentioned, your code would clash with someone else's workloads. Which brings us to our core question. Why are half your users experiencing 2-second delays? Because you wrote the code, but you don't actually know what happens when Lambda runs. Let me show you what is actually going on. We need to think of Lambda not as some magic server in the sky, but as a temporary factory workspace. When a request comes in, Lambda has to build a workspace just for you. AWS calls this the execution environment. And this brilliantly illustrates our first major point. It is a secure, temporary factory workspace built by Lambda to run your code without clashing with other workloads. Okay, let's dive into this. Section 2, the execution environment. We're going to map out the exact step-by-step mechanical flow of how this works. When your function receives its very first request, it enters the init phase. This is that notorious cold start. First, Lambda downloads your code. Then, it bootstraps your chosen runtime like Node.js or Python. Next, it runs your static initialization code. Now, this is absolutely critical. Static initialization is all the code you wrote outside of your main handler function. It imports libraries and sets up database connections. Then and only then, it enters the invoke phase. This is where your actual handler code executes to process the event. But here's the kicker. When it finishes, Lambda doesn't just destroy the environment, it freezes it.
Think about that. It's like a chef opening a brand new restaurant just to cook you one single burger. That is the init phase, and it takes time. But if a second customer walks in right after you, well, the kitchen is already open, the grill is hot, the chef just cooks the burger. That's the invoke phase on a warm start. Lambda bypasses the init phase entirely and jumps straight into your handler. Moving on to Section 3, the database connection trap. I want you to pay very close attention to this next part, because this is what causes massive application failure. Here is where people fail.
Notice the stark contrast in architectural approach here. If you put your database connection logic inside the handler, every single time that handler runs, it opens a brand new connection. It completely crushes your database, and it slows down the function execution. To implement this correctly as an AWS developer, you must pull that database connection object outside the handler method. When Lambda reuses that frozen execution environment for a warm start, those objects outside the handler remain initialized. You just write a tiny bit of logic inside the handler to check if the connection already exists before creating a new one. Literally, this one single change drastically reduces your latency.
So what happens when the stakes get incredibly high? Let's talk about Section 4, surviving flash sales. Imagine a sudden, massive traffic spike to your API that you absolutely have to handle flawlessly. Let's say you have a flash sale, and exactly 5,000 users hit your API at exactly the same second. Even with highly optimized code, Lambda has to spin up 5,000 brand new execution environments in parallel. That is 5,000 cold starts. If your business cannot afford that latency and you simply cannot lose those sales, you have to architect a solution. And the solution? You execute on a feature called Provisioned Concurrency. The crucial point here is that you explicitly configure Lambda to pre-initialize a set number of execution environments. Lambda runs that init phase ahead of time. So when those 5,000 users hit your API, the environments are red hot and ready to respond instantly. No cold start delay. They are ready to go.
All right, let's look at some very specific edge cases in Section 5, hidden traps and retries. For anyone taking the DVA-02 exam or, just managing production infrastructure, you must know these scenarios. How does Lambda handle errors during execution? Well, if your code times out or crashes during the invoke phase, Lambda completely resets the execution environment. But here is the trick. It does not clear the local/temp directory. Every execution environment gives you up to 10 gigabytes of scratch space in /temp. And because that directory content persists between warm invocations, a subsequent request reusing that environment can easily access leftover files. You must always account for that in your code by checking if the cache has the data you need or clearing sensitive data out completely. Also, you really need to understand the invocation retry trap. If you invoke Lambda directly and synchronously, like from an API gateway, and it fails, Lambda does not automatically retry. You just get an error back. But if you trigger it asynchronously, like dropping a message into an SNS topic, Lambda will automatically retry the failed invocation up to 2 times.
Section 6, let's lock this down. 3 rapid takeaways. 1. The execution environment lifecycle has an init phase for setup and an invoke phase for execution. 2. Static variables outside the handler and files in the /tmp directory persist across warm starts. 3. You mitigate cold starts by moving heavy initialization code outside the handler or by paying for provisioned concurrency.
And I'll leave you with one final warning. Never assume your execution environment will live forever. AWS terminates these environments every few hours for routine maintenance, even if they are constantly being invoked, so your application code must be fundamentally stateless. Keep that rule in mind for your next build, and you will never be caught off guard by the Lambda lifecycle again. Which leaves me with one final question for you to go check after this explainer. Are you absolutely sure your current Lambda functions aren't secretly holding on to state right now?